We're going to take a look at a video that Doane College made of two air pucks smashing into each other and then moving off. Now we're going to go ahead and take a look at that same video, but this time we're going to use graphical analysis to analyze the motion. So what I have shown over here is the x velocity of each puck. The red one corresponds to puck 1, which is the top puck, and the green one corresponds to puck 2, which is the bottom puck. And if I go ahead and I start this, it plays at half speed, and you can see, okay, right here, I'm going to back this up just a little bit. Okay, when we get to this point, okay, that's this collision over here. And you can see this thing was moving with fairly constant x velocity. This thing was at rest, no x velocity. And then all of a sudden we have this collision. This one speeds up, slows down, and then they move off with a constant velocity. Now, since they both have the same mass, their momentum and their velocity will parallel each other. So now what I want to show you is what happens if we add these two together, what we should get. Now the law of conservation of momentum, of course, tells us that the total momentum before and after a collision remains the same. So before the collision, the total was basically this up here because this is 0. So we should see if we add these two together, we're back to where we started. So let's take a look and see if we do. This time when I play it through, there will be a third line, and it's this orange line up here, and it's the sum of those two down here. And you can see it does stay fairly constant right up here at the top. It started up here and it remains up there. So just because these were moving in 2 dimensions does not mean that the total x momentum actually changed. Now we're going to go ahead and repeat the same thing. We're going to look in the y direction. Let's go ahead and take a look in the y direction. Alright, and so you can see before they collided, the y velocity was 0, or essentially 0, and then after the collision, the one has a positive y velocity, that would be the blue one up here, and the second one has a negative y velocity. They're moving apart from each other. And just like before, if we add those two together, we should expect them to add back up to what they were originally, which is 0. So if we go ahead and add in that last one, which is the sum of those two, hopefully what we see, if we replay this, is that it adds to 0. Alright, and you can see their sum is that purple magenta thing in the middle, and it does, it stays on 0. We get a little variation because of the way I clicked, but you can see that the total y momentum remains 0, the total x momentum remained constant. So the law of conservation of momentum applies in both the x and y directions together. It does not matter which direction an object is moving or if it's moving in more than one dimension.